Alright, this is Algebra 2 lesson, square roots of functions. Alright, so in this one we're going to learn how to graph the square root functions without a calculator. So the relevant points for this would be 0, 0, 1, 1, 4, 2, and 9, 3. Now for the most part I'm only going to use the first three, which are these points. Now, in case you're wondering how I picked this point, so I remember that this x would be the equivalent of that x, so the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So that's where I got those points, right? So to graph those, you would have these points right here, 0, 0, 1, 1, 4, 2. Alright, so if this is still a little bit confusing, make sure to look at the notes for A1, which I am a lot more methodical and slow on this one, so take a look at this. All right, for the domain, remember, we're looking for the farthest left point, and this one, the farthest left point is this one right here, whose x-coordinate is 0, including 0. So we're going to go between 0 and infinity, or you can also write it as x is greater than or equal to 0. Remember, greater than is to the right, and that one's going to the right. All right, on the range, it's also going to be the same between 0 and infinity. On the range, remember, we're looking for the lowest point, we're looking for the highest point. The lowest point again is going to be 0. The highest point, as this function goes farther to the right, it keeps going up. So that's why it goes towards positive infinity. Okay. And you could also write it as y is greater than or equal to 0. Alright, just to give you a few examples, just like last time on the quadratics, if I have a negative on the outside, that's going to make my graph reflect over the x-axis. Alright, so my normal point will still be that one, 0, 0. Right, but notice that I'm going off these points. Now the next one normally is 1, 1, so normally it's up here. Alright, but however, because this is negative, alright, I'm going to multiply all of the y coordinates, only the y coordinates times 1. So that would give me 0, negative 1. And the next one would be 4, 2. 1, 2, 3, 4. But now it's going to be 4, negative 2 because of this negative out here. Okay? Now that's all the points that I want to make you do. If you go to the right, that would be it. On this one, notice that this x plus 5, this plus 5 is inside the radical. And if it's inside the radical, that's going to make my graph move 5 to the left. Remember, x is a liar, so we're going to say this is going to be 5 to the left. So 1, 2, 3, 4, 5. Okay? And the points are going to be exactly the ones that we have here. 0, 0, which is that one. So I'm going to pretend like this is my new origin. So this is going to be point 0, 0. The next one is going to be 1, 1. So from here I'm going to go over to the right one, up 1. Then 4, 2. 1, 2, 3, 4, and up 2. And that's really all I need from you. I mean, you can also graph 9, 3. But if you graph those 3 points, I'm going to be okay with it. Alright, on number 4, same thing. But notice that this is minus 1, so I'm actually going to move to the right one. And this is not a mistake. Remember, x is a liar, so it's going to be the opposite of what you think. Okay, so if I go to the right one, I'm going to follow exactly the same points that I have here. 0, 0, 1, 1, 4, 2. Okay? So this point, if this is 0, 0, I'm going to make my fake origin right here. So I'm going to pretend like this is my origin. And from that point, I'm going to go 1, 1. And then 4, 2. Okay, so that's that. On the next one, notice that this negative 8, this minus 8 is outside of the radical, right? So this is outside of the radical. And if it's outside of the radical, this is going to move my graph up or down. That's going to move my parent function up or down. So in this one, this is going to be down 8. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. So this is my starting point, and this starting point is my fake origin. I'm going to pretend like this right here is point 0, 0, and because of that, I'm going to follow exactly the same points that I have at the top of this these notes. All right, so I have 0, 0, 1, 1, and then 4, 2. Okay, so that's that. All right, if you need to watch this again, make sure to rewind it. Let's go to the back page. Right on the back. One more time, if I have a plus 3, that's going to move my graph up 3. Right, so this is my starting point, and the same points that I had on the front, which are the points of the parent function for the square root, I have 0, 0, 1, 1, 4, 2. Okay? So this is, if this is my fake origin, right here, this is 0, 0. This would be to the right one up one, that would be 1, 1. And then finally, 4, 2, if this is my fake origin, that would be 1, 2, 3, 4, up 2. Okay, so that's that. Okay, now the one that's different would be this one, number 7. Remember, if you have a number that's being multiplied times that parent function, what happens is that this is going to vertically stretch. Alright, so this is going to be a vertical stretch by a factor of 2. However, we can find an easier way to do that perhaps if you don't understand now. This is not moving left or right, so I'm going to start at the true origin. So that's going to start there. Now what's going to happen after that though is that if I stretch by a factor of 2, that's the same thing as multiplying only the y coordinates by 2. Alright, so these new coordinates right here would be 0, 2, and 4, because if I multiply this times 2, then that's what I would get. Alright, so my first coordinate now is going to be 0, 0, which is what I have here. The next one's going to be 1, 2. So I have 1 and up 2. The next one's going to be 4, 4. So 1 from this point, 1, 2, 3, 4, and up 4. Okay. And then now, if you have any questions on this should be basically, this is the key, right? If you know how to do this, you'll know how to do the rest. So, if this one right here, if you have a negative, you're going to reflect over the x-axis. Or if you have a plus something inside the radical, that's going to be left h units. Alright, now the h just represents a constant number. Alright, so the h just represents a number. If you have a minus, that's going to be to the right h units. If you have a plus k, k represents again just another number. That would be up k units. Now notice that the k is outside the radical. Minus k would represent down k units. And 13, that would mean if a is greater than 1, like example 7, see how that's greater than 1. If you have a number that's been multiplied times your parent function and it's greater than 1, that's going to be a vertical stretch. So a vertical stretch, it's like grabbing that equation and stretching it this way. Alright? So vertical stretch. If it's less than 1, it's going to be a vertical shrink. Okay, now let me do just a couple of your homework instead of finishing this note. So if you go to your homework, right, notice that at first what I did here is I wrote the key points for y is equal to the square root of x. Okay, so let's go look at one that may look a little difficult, like number 5, for example. Actually, let's do number 6. Alright, so number 6, that is left 1. Remember, x is a liar. This is going to be up 2. And that negative is going to make it reflect. Okay. So we're going to start off at left 1. So left 1, up 2. Okay. And then now that we have our starting point, this is our fake origin. This is our 0, 0 right here. Now notice that this is negative. So all the points that I had here, and I'll rewrite them right here for you just to avoid any misunderstanding. If this is 0, 0, this is 1, 1, and this is 4, 2, then this negative right here, this reflection, is going to make all of these the opposite sign. So this is now going to be negative 1, and that's going to be negative 2. Okay? So now this point is going to be 0, 0. So that's my fake origin. Remember, my next point should be 1, negative 1. So from here, right 1, down 1. So that's negative 1 right there. On the next one is 4, negative 2. So from here you have 1, 2, 3, 4, and down 2. Alright, so this is the graph of the equation. Now let's do the domain and range. The domain on this one would be from 0 to infinity. Remember that we're talking about the farthest left point and the farthest right point. The farthest left point is 0, so that's where that 0 comes from. The square bracket is because it includes 0. All right, and the infinity is positive infinity is because it goes to the right. Now, because this one's going down, I always start from the bottom up, so my lowest point would be negative infinity. My highest point would be the y coordinate of that point, which is 2. And this is also going to be a square bracket with a 2 because it includes 2. All right, infinity cannot be included, so I will never have a square bracket. All right, please notice on this last few right here that these are quadratics. All right, so this should be parabolas. All right, so you should use these points right here. I'm not going to do this for you. Look at the notes A1 if you have any questions. Right on the back, notice I already actually did this. If it reflects, you have a negative. If it's stretched by a factor of 2, you have that 2. If it shifts to the left, make sure you write that inside the square root and write it with the opposite. If it's left, that's going to be plus 3. And then finally up 1 unit. All right. On the next one, it says shrink by a factor of a quarter. Shrink and reflect are basically the same, except the only reason they say shrink here is because this right here is less than 1. All right, so shrink, so all you have to do is rewrite it here. If it's going to shift to the right, you're going to write x minus 1 inside the radical. And if it's down 3 units, you're going to start there. All right, so just minus 3. On this one, always look for this is my starting point. This is my 0, 0. And because of that, I knew that I had moved to the left 3, which means you have a plus 3. And that negative right there makes it reflect. Remember, the original function kind of looks like that, right? So this is a reflection. All right, if you have any questions, make sure and ask me when you see me.